Hello all. So today we'll be seeing about addressing modes. Let's go into the topic. So these are the contents that we'll be looking at today. Introduction, types of addressing modes. So what is an addressing mode? So while you're coding or writing a programming language, that is while you're trying to compile a code, it will be easier or flexible when you have different ways to access memory or the data that is present in the memory of a computer or from the input output devices, and all these different types of ways that are used to access the data is called as addressing modes or addressing schemes. An addressing mode specifies how to calculate the effective memory address of an operand by using information held in register and constants contained within a machine instruction or elsewhere. So this is what is an addressing mode. Now let's see about types of addressing modes. First one, immediate addressing mode. In the case of an immediate addressing mode, the operand's value is mentioned explicitly in the instruction. Thus, we don't require the effective address as the operand is defined explicitly in the instruction. Example, add R2 hash 100 store R2 100H. Here, the add instruction would add 100 to R2's content, and the hash sign present in the front of the value would indicate the immediate value that is to be operated. So using hash will make the value to be indicated as immediate. Now, in case a value does not consist of a hash sign in front of it, it is then the address of any memory location. So the instruction used next, store, that is store, considers an immediate value of 100H as the address since it does not have an hash sign in front of it. The instruction stores the content that is present in the R2 at the memory location 100H. So next we'll see a direct addressing mode. The other name of the direct addressing mode is the absolute addressing mode. So over here, we're just going to use the data or the name given for the data itself directly instead of going for any other means like using hash, what we saw previously. So in this case, the instruction possesses the address of the actual location in the memory wherever the value of the given operand is stored. Here, the address of any memory location refers to the effective address. EA equals to A, that is effective address is equal to the address. For instance, add R to A, store R to B. So over here you can see that you're not using any hash symbol. It's just that you're referring to the name, just the name of the address itself, A, and then you're using it to store the value into B. That's all. So here the add instruction would include the memory location A, which consists of the value that is to be added to the register R2 content. In a similar manner, the store instruction contains the address of the memory location B, in which the register R2 content will be stored. So next it is indirect addressing mode. So over here in this indirect addressing mode, instead of using the address data or the name of the address itself, that is instead of using the previous example A, or like just going for the name or using a hash, we'll go for indirect method, that is using the register address for it. So we use a processor register to hold the memory location's address wherever the operand has been placed. This addressing mode would allow the execution of a similar set of instructions for various different memory locations. It can be done if we increment the content of the register thereby point to the new location every single time. So example, uh, um, the effective address is equal to the register of the address, and so load x3 comma x2 register address of x2, and then load x2 a. So here in this example, what's given is that the load instruction will ultimately load the values that are present at the memory location that are contained by the x2 register in the x3 register. The figure given below shows how the x3 register is loaded. So next we'll see about index addressing mode. So here in this mode, we'll be using the index value of the addressing mode and try to access the data. So the index addressing mode is pretty helpful whenever the instruction in the program accesses an array or large ranges of memory address. The effective address in such a mode is generated when we add a constant to the content of the register. The register content does not even change. So here is a symbolic representation of the indexing address mode. That is, you can see X and R. R is the register addressing mode, and X would be something that you're adding like a constant as it says above. and you change it to be an indexing address mode. So effective address is equal to x plus r. So now if you go on with a process or a program, so say load R to A, R2 to A, and then load R3 to R2, load R4 to 4R2, load R5 to 8R2, and load R6 to 12R2. So here, the first one is using the direct method for addressing to address the more address data, and the second method is by using the register value, that is the indirect method for addressing the data. Then the next three that we have, that is 4R2, 8R2, and 12R2. Over here, you're using the index values or the interesting address mode method. So introduction given above will load the R3, R4, R5, R6 registers along with the contents that are present at the successive memory address correspondingly from the memory location A. So this is what it's done using indexing address mode. So next we'll see relative addressing mode. In the case of relative addressing mode, the effective address or EA of the operand gets calculated when we add the content of the CPU register along with the instructions words address part. So over here, effective address equals to the displacement plus the CPU register. Here is a symbolic representation. So the symbolic representation for that is a constant or a word, and then the CPU register value, that's PC. So here is how the effective address for it is EA equals to X plus PC. Since the operand address here are found relative to the program counter, it is known as the relative address mode. So next we'll see about auto incrementing address mode. So this auto incrementing address mode are different or other extra types of addressing modes. So the auto increment addressing mode is just the opposite of the auto decrement mode. So there are two types in this other types auto modes, that is auto increment and auto decrement. So now we'll see about only incrementing mode. In the case of auto increment mode, the content present in the register is initially incremented, and then the content that is incremented in the register is used in the form of an effective address. Once the content present in the register is in the auto increment addressing mode is accessed by its instruction, the content of the register is incremented to refer to the next operand. So symbolically using register address and a plus sign symbol, that will be auto increment, and auto decrement would be register and the minus symbol. So the effective address here is the content of the register since it is enclosed using parenthesis. The content of the register that refers to a memory location gets incremented so that it can point to the next memory location in which the next operand gets stored. The auto increment mode thus helps in implementing the stack structure. So that's it for this video. Thank you.